I'm Bryce Corbitt,
I'm Pooja Patel.
and our project on the development and assessment of a mindfulness-based stress reduction mobile application is a WPI undergraduate computer science MQP.
For some context, the conversation and importance of mental health has grown significantly in recent decades. As a result, there has been an increase in the number of people interested in mindfulness. Mindfulness is a common practice done to alleviate anxiety and depression, but has no established structure or exercises for practice. A branch of mindfulness, called Mindfulness-Based Stress Reduction, is a meditation therapy that consists of established exercises that have been clinically proven to be effective in reducing stress, anxiety, and pain. The focus of this MQP is to continue the development of a mobile application to provide open access to mindfulness-based stress reduction resources for anyone to access and practice. This project originally began in 2015 with an MQP focused on compiling a list of technologies that would aid in the recruiting, adherence, and retention of MBSR training with college students. Furthermore, this MQP produced mock-ups for a prototype application. Following the outcome of the 2015 MQP, another MQP was established in 2017. The focus of this MQP was to improve upon the initial design, and this MQP resulted in a more robust mock-up as well as market research. Following this MQP, there was an IQP in 2019 that focused on the implementation of a prototype mobile application based on the specifications outlined in the previous two MQPs.
The visions of the app from both the 2015 and 2017 MQPs heavily focused on the ability to stream text, images, audio, and video. A backend was created for the prototype to fulfill these requirements with three main parts. The first part is a MongoDB database, which is responsible for storing content records and other server-sided data. The second part is a content management system, or CMS, that acts as the interface to manage MBSR content. Strapi, an open-source headless CMS, was chosen for its extensibility. With Strapi, each content type defined gets its own REST API that can be used from any web service or consumed directly by devices. The last part of the backend is the MBSR Server, a Node.js server that communicates directly with the app. It relays content from the CMS and manages other server-sided operations like account registration and authentication. Because all requests from the mobile app go through the server, any service in the backend can be modified without affecting the client-side API. The mobile app itself is written with React Native, a mobile framework that cross-compiles JavaScript to native app code. Our MQP had two primary objectives: to perform a complete rework of the app's video player that's used to stream video content, and create new infrastructure to obtain usage information when the app is in the hands of users. First, the video player. The original video player component was a simple web view, which is just a way to render HTML5 in the app. This player worked fine as a proof of concept, but it had a few problems. All HTML content under a web view is treated as a single component, so there's no way to see how users interact with the video player. The relatively small size of the video player on the phone screen also shrunk down the controls, making it harder to interact with. The React Native video library was integrated in place of the web view to render video. The React Native video controls library was also used to provide play, pause, volume, and full screen controls to the new player. We eventually forked this library to fine-tune the UI and add hooks to fire callbacks when each control is interacted with. In addition to revising the video player, we wanted to create a way to record and send usage information while the app is used in evaluation. Originally, we tried using Google's mobile platform Firebase, but we noticed a lot of events were being dropped in testing, and there wasn't a very simple way to export recorded events. We eventually opted to build our own in-house event system instead. The system operates from the MBSR server, and because a REST API already existed for the phone to connect to the MBSR server, it was easy to extend it to include endpoints for events. Events are also stored in the MongoDB database, which makes for secure storage and simple retrieval. To prepare for our evaluation, events were defined for navigation, button press, and each action that controls our video player. This system could easily be expanded upon in the future to support recording other in-app activities as well.
To assess the mobile application, we conducted user studies to test the video player component for its usability, user experience, and performance. Following our IRB approval, we began our recruitment of WPI students through email and social media. We provided interested participants with a link to a Qualtrics survey and a link to download a distribution of the application. The survey included an informed consent form and is followed by several tasks involving the video player component and questions the participant can answer. The tasks participants were asked to perform involved navigating to specific screens and pressing buttons on the video player in a predetermined order. Following the execution of the tasks, participants were asked where they would place the video player UI components to make it more attractive and if the UI components worked as they expected it to. Participant responses and their interactions with the mobile application were then recorded. In total, we had 30 participants submit the survey and 2,275 events recorded across 39 different devices. From the surveys, most people agreed that the play, pause, and volume sliders should stay in the bottom left corner and top left corner, respectively. Participants were split as to where to position the full screen button. Regarding the functionality, a majority of participants agreed that the buttons worked as intended. From the app interaction data, we learned that participants spend 5 to 10 minutes interacting with the app, and also several participants spent time exploring other screens on the application.
We're delighted to have had the opportunity to play a special part in continuing this project. We managed to improve existing functionality in the app, add new infrastructure, and get the app in the hands of real people for the first time. Results from our evaluation attest to the reliability of the backend and indicate potential to further expand upon the prototype in the future.
Future project work could involve the implementation of live streaming for real-time practice or expand the utilization of the account system. We believe that further research should be performed prior to continuing development such that a clear plan for how the app will be used in production is established.